Good afternoon, everyone. Welcome to this week's Monsoon Cafe. Myself, Samudra, and today I'll be giving a brief introduction and early researches associated with a topical variability, you can say, that is known as super cloud clusters. Now, if you see that the word super might seem as is a kind of a like superficial thing, but it's not. I'm assuring you that. So, coming to the basic question, that is what is a super cloud cluster? So the term super cloud cluster, or you can say cloud cluster, super clusters, was actually termed by two scientists, Hayase and Sumi, in their paper of 1986, where they ran an equiplanar model, and they found presence of certain large convective systems that was seen propagating eastward, which is a spatial resolution of several thousand kilometers, and for a period of about 30 years. Thus, after that, there was some observational studies, and the images that you see here in the slide are actually IR images photographed from the GMS, that is the Geostationary Meteorological Satellite, for 3 different days, 16, 18, and 20 April in 1985. So, as you can clearly see, the presence of a cloud cluster that is concentrated between 10 degree north and 10 degree south. And if you go through the arrow, then you can see that with passage of time, the cloud cluster seems to be propagating eastward. It is from 110 degree east. In the next image, you can see the cloud cluster propagated eastward at 140 degree east and beyond that. Thus, the observational evidence of cloud cluster is clearly seen here. And when I talk about cloud clusters, one of the pioneers in that field was Tetsuo Nakazawa, who published the earlier observational evidence of supercloud clusters, and he studied about these clusters and the structures that are embedded within these supercloud clusters. So Nakazawa, in his paper of 1988, he defined a supercloud cluster as an ensemble of cloud clusters having different life stages with an observed horizontal scale of several thousand kilometers, found near the equator during the active phase of an interseasonal variation. Thus, he said that these cloud clusters are a part of an interseasonal variation that is along the equator. Now, the plot that you see on the left-hand side, it is actually a time longitude section of transient weather, which is average between equator and 5 degree north from a time period of May to July 1980. So, from this plot, it is clearly, these are actually Euler contours. So Euler, as you know, serves as a proxy for convective activity. Hence, the presence of the supercloud clusters you can clearly see here. This is marked as A, B, C, and D. So the reason for taking this box I will come to it later on. Now, the evidence of the presence of supercloud cluster is clearly seen in the equator in using the satellite images also. But in order to study what are the structures that is inside the supercloud clusters, Nakazawa, what he did, he took a 3-hourly data set from the same GMS. He then extracted the mean cloud top temperatures, and he identified an intensity index such that he only took the data that have temperatures is less than 225 Kelvin, so as to just to extract out the deep convective activities. And using those intensity index, he again did a time longitude section plot. And you can see that the presence of these 4 supercloud clusters here, A, B, C, and D, they are seen propagating eastward with the passage of time. Although what is striking was interesting feature was that there was patches of certain cloud clusters that were actually propagating opposite to the mean propagation of the cloud cluster. So the first evidence of westward propagating cloud cluster within a supercloud cluster was seen in his by him in his observations.
You remind that two times not same.
Yeah. So,
I got confused.
So this is actually the domain that you have taken here. Yeah. So that is it. And the horizontal resolution was about several hundred kilometers over a time period of 1 to 2 days. So on the basis of what he observed, he made a hierarchy of different structures inside this interseasonal variations. So this is a schematic which shows that inside an ISB, there are certain multiple supercloud clusters that are seen propagating eastward as mentioned by these directions. And if we zoom in on a single supercloud cluster, we can see patches of cloud clusters which are seen propagating within their lifetime, with the mean propagation is towards the eastern side. So up till now, we know that what is a supercloud cluster is basically what are the structures that is embedded within the supercloud clusters, what is the propagation direction, and what are the spatial and temporal resolutions. So now after that, in order to understand what are the basic dynamics that is present within the supercloud cluster, Nakazawa he did use a technique called compositing. So compositing is what is it? What is it compositing? I will just come to it. So let's say
Didn't understand what you are talking that the westward propagation
yes sir.
is it real propagation or it is just because that development and decay has time scale which is slower than the westward propagation? What
Yeah.
is it?
It is actually, I will come to it later, but it is actually, it seems like it is a westward propagation. So there are different theories that says, some theories say that it is basically a visible westward propagation. Some say because of the subsequent formation of cloud in the eastern part and decay of the existing cloud, it seems like it is propagating west with the existing cloud. It is actually decaying to the propagating east and existing cloud is decaying towards the west.
But you cannot see that propagation, we do daily data. You don't use 3 hourly data.
Yeah, yeah.
Because there's a strong development cycle.
Yeah.
Yeah, that's the point they make.
Okay, okay. Okay, so coming to the technique called compositing. So basically what it does is that, let's say we have a precipitation peak data that is over a certain domain and over a certain time period. Now, in reference to that precipitation peak data, there are other variables associated with it. So if we take all those other variables and shift it left or right, such that all the precipitation points falls at a certain location, that gives us an composite of all those data points, you can say values, and just average it over that particular time. So basically what we did, all the let's say we have minimum Euler, negative Euler values over a certain region over a time period. Let's say we have 110 degrees, 120 degrees, and subsequently take all those points of highest Euler value, minimum negative Euler values, put them, displace them east to west such that every Euler values comes at a particular location, let's say the international deadline, for example, and then subsequently related to those all those Euler values, the other variables also shifted along with it. Thus, and then averaged it over time, thus giving us a composite plot as shown in the first figure. So this is an Euler composite plot, and this region actually represents the maximum convective activity that is associated with a particular all the cloud clusters that has been taken into consideration. Notice that the dotted areas that you see here are actually the negative Euler values, and subsequently these areas are the positive Euler values. Now, on the basis of this technique, we have also studied the wind composites for two different pressure levels, that is 200 millibar and 850 millibar, and subsequently the divergence fields. So coming to the first plot of 200 millibar wind composite, it is quite evident the presence of strong anomalous hysteresis, which is present across along the equator, with predominance, and it goes over the international depth. And this anomalous hysteresis is actually part of anomalous anticyclonic cell that is present towards 15 south. Also, there is presence of an anticyclonic cell towards the eastern side towards the northern side of the equator, but the values are not quite prominent as that of the southern. Also coming to the plot, the divergence plot. So the area where there is an anomalous hysteresis and also the minimum negative Euler values, you can see that the large divergence is seen at the same area, which coincides with this, also with that. Also, if you come second to the 850 millibar wind composite plot, the presence of anomalous westerlies is seen along the equator here, which is a part of a large band of winds that comes from the Indo-China region all the way from West Pacific. It moves southward until it reaches the Central Pacific area along the equator. Also, from this plot, one thing you can notice is the presence of an easterly wind that is known as easterly wind that is shown here, and it actually does give us a hint about the fact that there could be the low-level convergence of these winds that results in some certain cloud clusters, which forms eastward to the maximum or convective activity, which is the region is shown here. This is marked here. Apart from that, if we check the divergence composite for 850 millibar, the convergence region, that is a negative value region, is coincides with the Euler composites. Also, there are certain convergence region towards the east of this main convective activity region too, which also does support the fact that there might be some low-level convergence that could be seen in the real observations. So up till now, Nagasawa studied about the supercloud clusters and the dynamical characteristics that's seen around a supercloud cluster. But two questions does arise after this. Is the first is what causes general eastward propagation of supercloud clusters and the subsequent embedded cloud clusters opposite to that of a supercloud cluster. Secondly, how and why does a new cloud cluster form the east of an existing one? So we have seen evidences of some certain low-level convergence towards the east of the main convective activity. So why does it form and how does it form? So in order to answer these two questions, a number of studies has been conducted after that, which are mainly numerical studies based on simulations and models. And one of the earlier study was given by Lau et al., which is on dynamics of supercloud cluster, Western Windburst, 30 to 60 oscillations, and also a unified view. So in this study, they actually hypothesized saying that the westward propagating cloud clusters are associated with Rossby waves, which is produced at the development stage of 30 to 60 days disturbance due to mutual adjustment of the large-scale flow and heating. So they tried to explain the westward and eastward propagation that is mostly seen by saying that because there is a large-scale circulation and heating balance between the large-scale circulation and heating in the atmosphere. So if there is some external forces in the atmosphere, which is say like zonally asymmetric heating, then because of the imbalance between the large-scale circulations and the heating profiles, there occurs need to have an adjustment to that, and which results in the development of Kelvin and Rossby waves. So the of Kelvin waves supports the eastward propagation of a supercloud cluster, and because of this interaction between them, and the westward propagation of cloud cluster is mostly because of the heat-induced Rossby waves that is formed. Now, if there is an absence of any external forcing, if there is any absence of external forcing, then the Kelvin mode becomes the dominant mode for the propagation of the supercloud clusters. Thus, they tried to draw a parallel between the real-life situation where they said that the general propagation of supercloud clusters and embedded cloud clusters mostly are depends on the mixed interaction between the Kelvin and Rossby waves, and depends mostly on the external forcings that is present along the equator at the tropics. So this study actually kind of gave us an overall view of what causes the propagation of these cloud phenomena. Although it couldn't actually answer the second question, that what is a new cloud cluster from the east of an existing one. So for that, the paper by Chow and Lee in 1994, which was on tropical interest and oscillation, supercloud clusters and cumulus convection schemes, they actually came up with another hypothesis, where they tried to explain the formation of a new supercloud, new cloud clusters to the east of an original cloud cluster. For that, they ran some control experiment of initializing by random parameters, random perturbations, and these two plots, if you see here, are actually wind factor distribution of this control experiment. So their model was a 2D model. There is a longitude height model, and from this first figure, you can see the formation of a convective system here, which is shown by the updraft of wind at 130 degree east. So associated with this updraft are certain downdrafts. You can see here from the arrows is pointing downward. So in their control experiment, they actually made an assumption earlier that there exists a mean background easterly flow that is within the boundary layer. So in presence of that mean easterly flow. There is a subsequent downdraft, you can see, because of this convective activity going on. This downdraft, what it does is it pushes the air that is within the boundary layer towards the eastern side. So it pushes the air to the eastern side, and there is also a mean easterly wind that is within the boundary layer. This results in the low level convergence, and which is seen in the next slide, next plot, which is taken 6 hours later. You can see that there are formation of certain updraft of wind to the east of the main convective region, and this updraft of wind is because of that interaction of easterlies and westerlies in the lower levels. Thus, now the thing that comes to mind is that why does this emerging cloud cluster did sustain and this cloud cluster do decay? So it has something to do with the moisture supply that is coming. So the main background easterly flow that is there, it actually is the main cause for bringing the moisture supply to these cloud clusters. Now, when there is a new cloud cluster emerging to the east, this cloud cluster will get the abundant supply of moisture from this easterly, resulting in the growth of this cloud cluster because of the cis mechanism, and subsequently because of the moisture cut in this cloud and the existing cloud cluster, it will slowly decay in time until it kind of disappears. So the overall formation of a new cloud cluster to the east of an existing cloud cluster and the subsequent decay of a existing cloud cluster is what we see as the overall propagation of a super cloud cluster. So this was the hypothesis that they presented. Although they kind of mentioned about the decay of the existing cloud cluster, but they couldn't directly explain why does it seem as a western propagation of a cloud of the existing cloud cluster is seen. So after this study, a number of different studies has been taken out, has been conducted using different global circulation models or numerical method models, and two studies actually they tried to fill the gaps that was there from the study of Chow and Lin. So one of the study was the gravity of dynamics of variable structure supercloud clusters. So in this study, they agreed with the model that was means the hypothesis that was proposed by the earlier paper, and they said something. They said that the westward propagation of an